for the spherical polar coordinates, we have the r, theta, and phi. You must know where are those, and unit vectors are represented by r vector, theta vector, and the phi vector. Let me show it. Uh, okay, okay, and let me take a r vector, and okay, and just make a perpendicular to it, and okay, and this is the z direction, this is the y direction, and this is the x direction, and this is the angle that we are taking, this is the phi, and with the x axis, the angle with the x axis, and with the y axis we are taking, this is the theta angle, the z axis with the z axis, and this is the r vector. Okay, and this is represented by r, theta, and phi now. And because of the symmetry, we use this coordinate in the spherical symmetry mostly. And if you will get an idea, if you change the theta, this r vector is going to be make a circular path. Yes, similarly if you change the phi, then you can feel it is making the some spherical. If you change, if you fix a r, and probably I hope so you're getting the, if you change the phi, you will out of plane, it is the out of plane we are talking about, the phi angle. And if you go for it, and then they are also perpendicular to each other. If you, okay, let me show you, this is the phi angle, and this is the r vector, and this is the theta is in this plane only, mm, but perpendicular to r. Okay, and this phi angle is out of plane. I will show it to the dotted, and this is the phi vector, and this is the phi unit vector, and this is the r unit vector, and this is the theta unit vector. And basically they are perpendicular to each other, and they have to also follow the rules, as that we have discussed the z cap is equal to x cross y. You have to follow that rule. Similarly you have to follow this rule here also. R cap is nothing but theta cross phi cap. You have to follow these rules. Basically they are perpendicular to each other, simply it is representing. Okay, the other is spherical coordinate. The r value is varying from 0 to infinity, and let me write in this form, 0 to infinity, and phi value we are varying from 0 to 2 pi, and theta value you have to specify it, because it is varying from 0 to pi only. Very important. Thank you. It's okay, then you have to take some cap. Okay, let me discuss it here only. Let's suppose I want to take the projection of this r vector in this, then it become in this direction, then it become I hope so you can see it in if I want to take the r component vector in this direction, then it is this is the theta. Yes, this is the r sine theta in the r sine theta. And again you, because you want to find out the x value according to the coordinate r theta phi, then you have to again take the projection to this direction, then projection in this direction is r sine theta r sin theta is already there, and then you have the cos phi. Yes, then I should write r sin theta cos phi. And similarly for the y you had the r sin theta only in this plane, and then you have to take the projection in the y direction, then it is r sin theta sin phi. Okay, and similarly if you want to take the projection of the r in the z direction, it is simply the r cos theta. And then it come out to be, if I write the r coordinate according to the Cartesian coordinate, then it we know it, uh, yes, z cap, and then we change put the values of the x we are getting r sin theta cos phi and x cap plus r sin theta uh, sin phi and y cap, and other is uh, r cos theta, yes, z cap. And after that we have to differentiate it. Let me try. Let's suppose you want to find out the complete derivative of the r, then it is r is nothing but r vector divided by r and dr, complete derivative of the r vector, and plus dr with respect to the theta, d theta, and dr vector with the phi and d phi. Okay, and these we have already discussed. These components we call it h1 e1, and this is h2 e2. Probably we are going to find out the value of the h1 h2 h3 and e1 e2 e3. And e1 e2 e3 are nothing but, here we are talking about e1 e2 e3 r theta phi. Okay, this is r cap, theta cap, and phi cap. Let me show to you these things. h1 is the magnitude of r vector divided by differentiating with respect to the r and taking the magnitude. First find out the r vector, differentiate with respect to the r, then we are getting sin theta. R we have to differentiate with respect to the r, and then r vector we have to differentiate with the r, then sin theta cos phi x cap plus sin phi sin theta sin phi and y cap plus r no, we are differentiating with respect to the r, yes, then we are getting this. We have to find out the magnitude for this. Okay, finding out the magnitude is the squaring of this, square of this, and square of this, and just under root it, you will get the answer, magnitude. Okay, the magnitude is, now we are getting, if we find out the magnitude, I have given the name for it h1. h1 is nothing but hr, we call it hr, and it is nothing but the under root value and magnitude. We have to find out the magnitude. Yes, okay. The first is, I think, cos sin square theta cos square theta plus we are squaring, yes, we are squaring the coefficient of the respective, and then we are getting this. Okay, phi, okay, phi, and then under root no r cos square theta, and then we are taking out the sine square common, then it remains if I take out the sine square theta common, then it come out to be cos square phi plus sine square phi, then it come out to be 1 and plus cos square theta. Then we are getting h1 value, yeah, hr value we are getting, how much we are getting, and again we are getting 1. And similarly you find out the value for the theta. H theta is nothing but differentiate the r with respect to the theta and find out the magnitude for it, then you got the answer r only, okay, the magnitude r. And then h phi you will get the, with respect to the phi you're differentiating and finding out the magnitude, then you will get this answer, okay. Then you have to remember these h1 hr h theta and h phi, and then probably you will get the, it make more simpler to discuss it, okay. And the other is uh, dr. Now we can represent the dr is the form of h1, okay, we are now discussing hr and dr r cap and then let me check it out, yeah, okay, dr, we do not write the vectors for it, okay. And h theta, d theta and h phi and d phi, and we are getting the value now 1, this is dr only, and this is r into d theta plus, okay, and this is r sine theta d phi, yes, okay, dr value we are getting. Let's suppose we had to find out the velocity component. Velocity component is nothing but differentiating with respect to the t, then we will get the complete, yeah, I have forgot to write is these unit vectors should be there, yes, unit vector should be there because it is the r vectors, okay, sorry for that. And this is theta and this is the phi, and this is the r vector, theta vector and phi vector, and then probably you will get if you find out, you will get unit vector, it is the r vector no yes, r dot r cap plus then if you differentiate it with the r theta dot and then phi, and then if you differentiate it, it remains the same, and then phi dot and phi cap, okay. And these are the respective component. Vr component we call it, and this is the v theta component we call it, and Vr component is r cap, r dot only simply, and this is r theta dot, and this is v phi is r sine theta simply, and phi cap. These are the respective velocity component in the spherical coordinate. They are different in every direction, you have to remember it. Let me take one example to simplify it. Let's suppose you have a pendulum, okay, let's suppose you have a pendulum. It make very simple. Let's suppose this is the mass m here, mass m, let me write it here only, and then this is the L, let's suppose L, then this is the R. Yes, okay, let's suppose the pendulum is moving in this direction, and then okay, yeah, yeah, okay, and then this is the R dot vector direction. Yes, R vector, yeah, L dot we can say. Let me take it R only, so it makes simpler. Then this is the R vector direction. This is the perpendicular to it, the plane. This is the theta. Then this is the theta dot direction. Then the velocity component of this mass in the theta direction is r into theta dot. Just remember it, r into theta dot. Let's suppose if it is pendulum is spherical pendulum, then you had a different component. If it is spherically moving, I can't represent it here properly, but it is the perpendicular in the perpendicular direction, then it come out to be this factor. Okay, I most probably I should not write here because I can't shown the phi component here. Let's suppose this is the z direction. Let me try if I can. Let's suppose this is the, okay, it is not too simple. I think it is the perpendicular direction only you will get the, if it is spherical pendulum, it means it is moving in 3 dimension. Right now the pendulum is only moving in the 2 dimension. If you want to take the, if you take the spherical pendulum, then you have to take the other component also, r sine theta phi cap. Be careful, it is just check it out, and it is the perpendicular in all the direction. In the phi direction you will get this component, in the theta direction you will get this component. Okay, and yes, spherical coordinate, let me summarize all the things again. And we have the x is r cos uh, r cos phi and sine theta, and y is r sine phi and sine theta, and z is r cos theta simply. And then r quantities come out to be, if I write the r quantity, then it come out to be r cos phi cos sine theta x cap plus r cos r sine phi and cos theta y cap, and r sine r cos theta simply z cap. This is come out to be r, and if I find out the dr element, then it come out to be dr r cap plus uh, r theta d theta cap and r sine theta d phi and phi cap, simply it come out to be. And if I want to find out the area element, then suppose I want to find out the area element, then let me write it general form of the area. Let's suppose I want to write the direction of the area element is in the r cap direction, then let me r cap the direction of the area element. Then here I should write the h theta h phi d theta d phi. That's why if you put the values let me again show to you h1, h2, h3 are here the values represented by, okay, let me here only write it. H1, H2 and H3 are represented by HR, H theta, H phi, and their respective components are come out to be 1 R and R sine theta. You have to remember that. And then if I put these values, you will get dr vector in the r vector direction. Area element come out to be r square sine theta d theta d phi. And yes, you have to you have used many time when dealing with the integration part, and there we have deal many times in the r vector. This is the basically the direction of the area element. If it is this one, then we have to use this area element this way. Let's suppose dr, if I want to find out in the theta direction, then the area element is come out to be in the theta direction, and it come out to be hr, h phi, and hdr and d phi. And then just put the values and you will get it. HR is 1 only, and then yes, dr d phi and theta cap. Similarly, if you find out the phi component, if the area element phi component of the area element, then it come out to be uh, h hr h theta and dr d theta uh, in the phi direction. And if you put the values, you will get r dr d theta and phi cap simply. And let's suppose now the area element is interesting. Area element d2, we represent it, and it come out to be directly. If I want to make it general, then hr h theta h phi and dr d theta d phi. And if you put all the values, you will get dr and dr sine theta dr d theta d phi simply. Okay, and then let's suppose you want to find out the gradient of a scalar quantity in the polar coordinate. It is different from the Cartesian coordinate. uh, it is not just so simple. Then let me write it general first. The general formation is curly t by curly r, and then r cap, and you have to divide with the factor. It is hr. You have to take care of this. And then let me write the h theta and curly t by curly theta, and then theta cap. Just I had h theta. I think you can get the things. This is h only, and h phi, and then curly t by curly phi and phi cap. Okay, and after that, putting the values of hr is 1 only, and then it come out to be simply curly t by curly r, and then r cap plus 1 by r curly t by curly theta and theta cap, and plus 1 by r sine theta curly t by curly phi and phi cap simply. Okay, let me any vector. uh, V is any vector. Let me represent it by, yes. Okay, we want to find out the divergence of it, and then the straightforward, just write the formula, and HR H theta and H phi, and then curly r by curly r, and this is come out to be h vr component of the velocity of r in the r direction let's suppose this is the velocity, then in the r direction velocity, in the theta direction, and in the phi direction, and r cap, no sorry, there is no cap because it is a scalar quantity come out to be, and with respect to the theta, and you have the v theta, v r, and v phi, and then plus with respect to the phi, and v r, v theta, and v phi similarly, and okay, then this is the answer you will get simply. Let me put in the brackets. Okay, uh, that's it for the this, and let's suppose I want to find out the curl of the any vector quantity v, then it come out to be 1 by hr h theta and h phi, and then hr r cap, h theta cap, and h phi cap, and r cap and theta cap, and phi cap, and hr and hvr, and then h theta, v component the v with this theta, and h phi and v phi. Just put the values, you will get the answer. It is very straightforward. Just put it the h r h theta h phi value. We already know. Let me write it once again. Just put these values, and then 1 r and r sine theta, their respective uh, h r h theta and h phi components. Okay, thank you.